Welcome, ladies and gentlemen, to this video lecture. Let's take a look at this example. We want to determine all the roots of the following polynomial. Okay, so first thing we notice here is that our polynomial is over C. So that means if we find a complex root, that does not necessarily mean that the conjugate of the root is again a root. So just be careful. So using the factor theorem, let's start guessing roots. So using the factor theorem, so for example, we can guess that 1 is a root, and what we will see is if you work that out, that is not equal to 0, so 1 is not a root. 1 is not a root. And you can try -1, and you will see that is also not equal to 0, so -1 is also not a root. And you can try I. That's also not 0, so I is not a root. And if we use -I, then we see that we will get 0. So the arithmetic I will leave as an exercise for you. And notice here, -I is a root, but I is not. So -I is a root, but its complex conjugate I is not a root. And why is that? That is because there we've got a complex number in our coefficients. So remember that theorem only applies to real polynomials. When all the coefficients are real, then we know that the conjugate of any root is also a root. Okay, so now performing long division. So what will we do? We will perform long division on our polynomial, and what we will see is that our remainder is equal to 0. That we will also leave as an exercise, and we will see that f of x factorizes as follows: x plus I 2x squared plus 3ix minus 1. Okay, so now we also want to factorize this quadratic over the complex number. So we see this is a quadratic, and one of our coefficients is a complex number. And there are a couple of ways of doing this. The suggested method in our textbook is to complete the square. So we complete the square of this expression. So complete the square of the following: 2x squared plus 3ix minus 1. And what do we obtain there? When we complete the square, we obtain 2x plus 3I over 2 square root 2 squared plus 1 over 8. Okay, so perhaps the easiest to understand how to proceed now is to perhaps introduce a new variable. So let y be defined as square root 2 of x plus 3I over square root 2, or 2 square root 2. Let's write it that way. Then let's see, x is a root of our polynomial 2x squared plus 3i x minus 1 if and only if y squared is equal to minus 1 over 8. So y should be plus or minus I over 2 square root 2. And now we can solve for x. So we've got, so now we plug in again what is y, 2x plus 3i over 2 square root 2 is equal to I over 2 square root 2, or square root 2 x plus 3i over 2 square root 2 is equal to minus I 2 square root 2. So if we solve here, what do we get? We solve for x, and we get x is equal to minus I over 2, or x is equal to minus I. So that means that this expression, x squared, 2x squared plus 3ix minus 1, this factorizes as x plus I over 2 and x plus I. Okay, so that means we can factorize f of x as follows. We've got the one root, which was minus I, and we've got this repeated root, minus I again, and x plus I over 2. So minus I over 2 is a root. So the roots are minus I, so minus I occurs with multiplicity 2, and I over 2, which occurs with multiplicity 1. Okay, and there are the three roots of this cubic polynomial. So see here, our polynomial had degree 3, and counting with multiplicity, we have found all three roots of our polynomial. Good, and that is it for this example. I will see you in the next one.